Okay, lesson 8. Graphing from standard form. ax squared plus bx plus c. You want to find the vertex and describe the graph from standard form. So what do the vertex and the axis symmetry have in common? Well, let's look at what the vertex formula is.
So vertex form is already in the notes, pre-printed. Here it is right here again. If it comes up something later in the video, that's because I had to change it because I accidentally put the wrong one in.
So let's see. This should be x minus negative 4. So our vertex is negative 4, negative 5. The axis symmetry is x equals negative 4. Over here, our vertex is at 2, 7. And the axis symmetry is at x equals 2. Now, standard form, again, is ax squared plus bx plus c equals 0. Yeah, that's a horrible looking x, I know. Let's clean that up. Okay. If a quadratic is in this form, the axis of symmetry is x equals the opposite of b over 2 times a. This is also the x-coordinate for the vertex. So whatever that ends up being, that is the x. Just like here, the x-coordinate is in the vertex. And the axis symmetry is that x-coordinate. If a is greater than 0, it opens up. It's positive. It's a smile. And if a is less than 0, negative number, it opens down, like a frown. Another useful point that's easy to find from standard form is the Y-intercept, which is c. So that's another point we can plot. So let's look at this information, these quadratics. Remember, we have A, B, C. I suggest getting in the habit of identifying them like this. So, which way does it open up? Well, 3 is positive. The axis of symmetry, x equals the opposite of b over 2a. That's negative 6 over 6. So x equals negative 1. Now, that is the x-coordinate of our vertex. How do we find the minimum? The y? We plug this negative 1 in right here. Now, the nice thing is, if you're using your graphing calculator, watch. Nope, not a regular calculator, graphing calculator. So, 3x squared plus 6x minus 5. We look at the table and we look for negative 1. And there it is, negative 8. Okay? So negative 1, negative 8 is our vertex. Now you can actually plug it in. Negative 1 squared is 1, times 3 is 3. Negative 1 times 6 takes it negative 6. 3 minus 6 minus 5 will get you negative 8. Okay? Or you can use the tools you have in hand. Now, again, as we talked about, if it does, let's say negative 1 was not one of the x-coordinates that showed up here, or it was a number that didn't show up, you could hit second window and put your number in right there at table start and then go back and look for it. Or you can come down here and ask the independent variable. So hit enter there, and then when you go back to your table, you can put in negative 1. And it will give you your answer. So if the number you're looking for is not here, you can just go down and change this to ask mode instead of auto mode and look on the table. Maximum or minimum. Well, if it's opening up, it's a minimum. The Y-intercept is C, so -5. And the domain is going to be, again, negative infinity to positive infinity. And the range, how low does it go? -5. Sorry, my bad. I'm thinking about vertex form. The range, you're going to look at your vertex. How low does it go? -8. How high does it go? Positive infinity. Okay, so on to the next one. A is -1. B is 2, and C is 3. Since A is negative, it's going to open down. X is symmetry, opposite of B over 2A. That's -2 over -2, and this time we get +1. So my vertex is at 1, comma something. So I'm just going to put this one in my calculator. Y equals, clear it out. Remember, gray negative key, x squared, contain my x squared plus 2x plus 3. Go to my table and look for 1. There it is, 4. 1, 4. Again, I can plug 1 in. Pretty simple. 1 squared is 1 times negative is -1. 2 times 1 is 2 minus 1 plus 3 is 4. Pretty easy to do in your head, but you do have the calculator to confirm. Since it's opening down, we're going to have a maximum. The Y-intercept is C, which is 3. The domain of all of these almost always negative to positive infinity. And the range, we look right here. How high does it go? Or how low does it go? Negative infinity. How high does it go? 4. Sorry, that should be a bracket. And that's it. Okay, provide the information, use at least 5 points. Once again, use your calculator. So, A is 1, B is 6, and C is -8. So, A is positive, it's opening up. X equals the opposite of B over 2A. That's -6 over 2, which is -3. My vertex is at -3 something. And I'm going to need 5 points, so I'm going to put this in my calculator. Again, Y equals, clear, x squared plus 6x minus 8. Graph. So my vertex is off the chart. So I'm going to look at -3, and it's -17. And I'm going to use these points to put on my graph. Now this is one to have, it's hard to have all your points on your graph. So -3 again is -17. So let's look at your calculator. It disappeared here, but you can see. We're going to put the points like 0, -8. And 1, -1. Once again, I'm just taking these right off my calculator. And -1, -13. And you can use your extra paper here, and maybe go down to -3, and kind of estimate -3, -17. There's your other point. And then your other -13 is going to be a -5. Just try to make that kind of even. -5, -13. And your other negative 8 is going to be at negative 6, negative 8. And your other negative 1 is going to be at negative 7, negative 1. And that kind of gives you a good idea of what it looks like. That was a horrible parabola. So, does it have maximum and minimum? Obviously a minimum. The y-intercept, c, negative 8. The domain, again, is going to be negative infinity to positive infinity. The range, how low does it go? Negative 17 inclusive. How high does it go? Positive infinity. And where are the intercepts? It looks like, again, you have to say between negative 7 and negative 8 and 1 and 2. Okay, and last but not least, A is negative 2, B is 4, and C is 9. It's going to open down because A is negative. The x is symmetry. X equals the opposite of B all over 2A. Well, that's negative 4 over negative 4, so that equals 1. So again, the vertex is going to be 1 comma something. So I've already put this in the graphing calculator. Let's see what it's going to look like. It's going to be off our chart a little bit. So let's see where 1 is. 1's up to 11. So just barely off the chart. So we can put 1, 11 right there. Not too hard. Obviously, it's a maximum because it's opening down. The y-intercept is 9. It's our C. The domain, again, negative infinity to positive infinity. That's not changing. The range, how low does it go? Negative infinity. How high? Right there, 11. The roots, we'll get to that. Let's put some points on here. So, negative 2, let's see, negative 2, negative 7. Negative 1, positive 3. 0, 9. 1, 11. We have that. 2, 9. 3, 3. There's the mirror image there. And 4, negative 7. There's our mirror right there. So, our estimate on the roots, again, look where it falls between. It looks like it falls between negative 1 and negative 2 and 3 and 4. That's it.